Good morning. My name is Elizabeth Andrew, and I'm with Materials Sciences. I'm excited to share the results from our Rapid Cure honeycomb repair project. Before we dive into the technical, let's talk a little bit about MSC. We've been in the composites industry for over 50 years. We are headquartered in Horsham, Pennsylvania, which is near Philadelphia. Our projects span from cradle to grave, including design and analysis, material characterization and prototyping, all the way through to production manufacturing. We have 45,000 square feet in Greenville, South Carolina for specialty textiles and composite production, as well as 12,000 square feet of engineering and manufacturing space in Huntsville, Alabama. As you can see on this slide, we have a wide range of capabilities and many examples of successful product transitions. MSC is pleased to have been awarded an opportunity to work on this Navy challenge, which focuses on streamlining composite repair processes using a novel, lightweight structural filler formulation. Our goal is to reduce the time required to perform a honeycomb repair on a sandwich composite. As I'm sure many of you are aware, this is currently a long process, particularly if core splice is required. The target metrics are shown below, with the key focus being on a 1-hour time to sand and an 8-hour cure profile without external cure equipment. And that's very important. All of this is ambient cure work. So let's talk a little bit about why the project is important. For operational use, system maintenance is a critical focus area for both operational tempo and platform lifecycle costs. When you think about a sandwich composite structural repair, and sandwich composites exist all over high-performance platforms such as in fixed wings, rotor blades, flooring, wall panels, refueling booms, all over. There are lots of different considerations, such as the adverse effects on mission readiness, the time to repair, the labor involved, and the downtime of the asset that come into play when we talk about these structural repairs. MSC's technology can cut down these adverse effects by a factor of 7. And that's why this repair material is so crucial. We're saving hours in the repair process, which translates to a significant cost savings. And those cost savings are the result of a ripple effect. Time saved during cure and potting enable faster reskinning, which enables the artisan or technician to perform more repairs during their shift. Additionally, the temperature versatility means that repairs can be performed outside of conditioned repair depots, so they can be performed on the component where it is without relocating. Building off that understanding, we can talk about MSC's solution. MSC's low density and quick curing honeycomb filler enables a 70% faster repair. This is achieved with a 1-hour time to sand versus 8 hours in the baseline. It's fully cured within 24 hours, and it's a drop-in replacement to the current repair procedures, so there's no adjustments needed to current operational procedures used by artisans and technicians who were performing repairs, or even fabrications for that matter. It's self-extinguishing, and that added fire retardancy enables the material to be used in places the legacy material wasn't able to. Finally, the system cures even at very low temperatures, which makes it a valuable solution for field and battle damage repairs. As with any material development, it's critical to plan the technology maturation dates in order to better transition the technology. We fully understand that an excellent technology does not benefit our service members unless it can be produced at scale. As you can see, MSC has already achieved TRL 4 and expects a minimum of TRL 6 at the completion of the Phase 2 effort. If a Phase 2 option were to be awarded, MSC expects to further the technology to TRL 8. Here's a look at the data comparing MSC's repair solution with the systems currently approved by NAVAIR guidance. It clearly demonstrates the significant reduction in maintenance or fabrication time, again with that 1 hour time to sand versus an 8-hour time to sand in the legacy materials, as well as a 20-hour cure time, a demonstrated 20-hour cure time versus 5 to 7 days in the legacy materials. Additionally, the lower exotherm temperature of 104 Fahrenheit means that large quantities of resin can be mixed and used, thereby enabling larger repairs to be performed without negative exothermic reactions. And so the current demonstrated repair increase is 50% greater radius. Other benefits, again, include that 32-degree Fahrenheit minimum cure temperature, so that enables field repairs in a variety of ambient conditions. Room temperature compressive strength above 10 KSI, and that added fire retardancy, which will enable the materials to be used near high operating temperature components. In order to transition this material beyond Phase 2 to the fleet, we're looking for partners and advocates in the FRC and the primes who can specify the material into their repair guides. We expect our primary transition advocates to be those maintaining the fleet, such as depot teams, primes, and suppliers. Others that will likely advocate for the adoption of this material are fleet commanders and squadron commanders who are waiting for their assets to be returned to the field. The initial transition platforms expected are advanced naval vertical lift platforms like the V-22 Osprey and the CH-53 Super Stallion. But many other platforms will benefit from a material like this, including fixed wings such as the F-18 and the F-35. MSC's market analysis indicates that a wide range of applications would also benefit from this material, including commercial aviation, space platforms, both commercial and defense, as well as high-performance sports, marine craft, transportation, like ground transportation, green energy, like wind turbines, as well as construction. We expect interest from many of these markets due to the increased profitability made possible by the rapid curing system. As many of you know, the successful commercialization of this project will result in a cost savings for both the Navy and other defense applications using the material due to the efficiencies in scale. MSC plans to achieve this commercialization by producing the compound in-house and packaging it appropriately. In other words, our business model will be direct sales. We're currently seeking support from PMA 260, and in parallel, we're identifying supplemental funding with OEM partners who really want to embrace this innovation. Thank you so much for your time and listening to this presentation. We here at MSC are eager to hear from you. Please reach out and let us know if you have any questions or what your needs are, and we can transform those needs into the material solutions of tomorrow. Thank you.